Okay, here I'm back. After insulation, we go into windows, and let's start immediately. And I will be also uh, that will be approximately around 9 slides, approximately 10 minutes, I guess. So let's start with the energetic characteristics of windows. So we have the U value of the entire window. Then we have the one from the frame, the U value, and for the glazing. It's actually a little bit difficult and complicated to calculate the U value from the window by your own. So the producer actually have already the U value for the whole window available. However, if it's not available, this table can give you some ideas, and you have to fill in these ones. If you know from today on, a double pane window, for example, plastic or steel frame, um, the plastic, steel, and aluminium frame, depending. And what I want to show you on that slide is that we actually have uh, uh, two different kind of values. So we already discussed the U value, so no more talking on that. But we have a G value, and uh, we have the solar heat gain coefficients. That means, I think in the States it's the G value, and in the other ones it's a solar heat gain coefficient, the SHGC. This is used also for the Edge software, the SHGC, and I will focus on that one. So you should actually more considering that one than the G value. Anyway, in this presentation, uh, they mentioned the G value here, so I also will mention that. You maybe remember, I think 2 or 3 presentations ago, we had the thermal comfort on and the surface temperature. So here, for example, it shows it on the glazing here. Outer temperature 10, here the same, and then room temperature 8. No, not room temperature is 20 and surface temperature is 8. And for here, room temperature is 20 and surface temperature is 15. Why is the surface temperature higher here and gives a better thermal comfort? Because of the daylight transmission of the, not really, no, of the G value, which is lower here. So, and again, I did that. So you have and also the U value has changed to 1.1, which was before 3.0. So this one is a heat protection glazing with low E coating, and you can see it here in light blue, argon gas filling. You will get a little bit more on that one. But before we go to the filling and the efficiency of windows, I want to give you a small inside look, and particular on the spacers. The spacers are the one between the two glazings, and most of the time aluminium is used, which has a very high conductivity, and that leads actually to a weak U value. So here you have different kind of spacers, and most of them are a kind of a rubber plastic. It's a thermal defense, and it's 65% warmer, for example. So you can do already something on if you look at the windows, which kind of spacer they have. Here you also can see that on the thermal imaging. And so, for example, for the spacer, if you use aluminium, very high conductivity, 200. If you use polycarbonate, it's only 0.19. So it really makes a difference. And let's focus on the high efficiency frames and entire windows. So in the past, you were just, I'm putting myself here. So this one is actually the cheapest one, plastic steel 4 chambers, and the glazing is just a double plane, and the U value is 3. So most of the time what we are interested in is really the U value. And here you can see the different fillings, double pane, but argon, filling argon, and then there's krypton. This must be something from Superman, I think, was allergic against krypton, but I think that's not really relevant anyway. Of course, you can see the 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 pricing, of course, is much higher than the standard one. So it's up to you to consider if that is energy saving, energy efficiency saving. Yes, it is. Is it money saving? Well, that depends on your costs, and the Edge software can help you with that, because you can put different kind of window frames there, and they will do a calculation for you there. There are easier ways to change. So if I look, for example, at my window at my apartment, this one is moving freely backwards and forwards, so there's no insulation. So this could be actually sealed with a silicone seal inside and outside, but preferable inside. Then you have here from the window frame, you have this installation form and some layers here to also make it airtight. So we are not talking about cold bridges here. We are talking about airtightness for windows. And of course, you can have that expanding sealing tape, which you can put on the windows. So this is something which we probably also will discuss in the second module when you winterize, getting your building ready for the winter. So by the way, anytime you can stop the video and read the thing when I'm in the way. So I'm busy with moving myself backwards and forwards, but I also want to show you that I'm around and not only my voice. Um, so, and that's actually already finished with the windows, and now we are just jumping, because it's nearly the same. We are jumping to the doors, and there's not much to add there, because windows are treated in the same way. Doors are treated in the same ways than window. The only thing which I want to add is you have uh, already 2, 3, 4 pane glass window doors in aluminum frames, with some thermal breaks. And then you have, for example, a passive house door with a U value of 0.8, which is pretty good. And the last one which I want to show you is the automatic self-closing device for entrance doors. That means this device should be there to keep the door quick closed as possible. And as you have it already, in most skirts I've seen, or other places, you have a double door, which is giving a buffer zone in to enter the building. Okay, so that was windows and doors. And thank you for listening, and I hope you enjoyed. Next video is in the making, and it will be on shading.